This is a recall question. So we have to understand that the amplitude of the wave is actually the distance from the equilibrium position, which is represented by the dotted line, to the highest point of the wave or to the lowest point of the wave. So amplitude is well represented by option B. However, there are some students who have this misconception that the amplitude is actually from the highest point to the lowest point of the wave. So this is not right, and we have to bear in mind not to make this mistake. Okay, to answer this question accurately, we need a protractor. So because of this barrier, the light ray from the lamp can only be reflected off this point to the observer's eye. So we can draw this ray here with an arrow, and we should draw a normal that is 90 degrees to the mirror dotted line, because normal is an imaginary line. Then let us measure the angle of refraction. Okay, angle of refraction here is about 62 degrees. And let us draw the angle of incidence, which is also 62 degrees. Okay, with an angle of incidence of 62 degrees, we can see that the ray must come from lamp C. So C is the answer. There are two parts to this question. So first of all, we have to determine whether the lens is a converging or a diverging one. Okay, a converging lens, when light passes through it, it will bend the light inwards. And for a diverging lens, it will bend the light outwards. So we look at this ray here. After passing through the lens, it actually bends inwards. So it has to be a converging lens. Okay, next we have to look at the focal length. After the ray has passed through the lens, they actually move further and further apart from each other. So that tells us that they will not converge on the right side of the lens. So that means it will form a virtual image on the left side of the lens. So what we do is that we have to draw dotted line backwards. Okay, that means that a virtual, magnified and upright image will be formed on the same side as the object, and this kind of image is only formed when the object distance is less than one focal length away. So we can conclude that the focal length must be more than 10 cm. So answer, it will be A. X-ray, being a component in the EM spectrum, is a transverse wave, and it travels at a speed of 3 × 10 to the power of 8 meters per second in vacuum. So answer is D. Okay, in this question, we are being asked if the frequency of a note increases, what will happen to the wavelength or the speed. Okay, speed is related to the medium at which it is traveling in. So since both the sound travels through the same medium, we can say that the speed is constant. And using the formula V is equal to F lambda, if the speed is constant and the frequency increases, the wavelength must decrease. So answer is B. the note will have a smaller wavelength.